the other and is occupied by a single unpaired electron. Now, consider a carbon atom having atomic number 6 in the ground state. Its electronic configuration is 1s2, 2s2, 2px1, 2py1, 2pz0. On excitation, an electron jumps from the 2s orbital to the 2pz orbital, resulting in an electronic configuration of 1s2, 2s1, 2px1, 2py1, 2pz1. In order to form 4 sigma bonds with other atoms, the 2s, 2px, 2py, and 2pz orbitals of this atom intermix. This process of intermixing of atomic orbitals is called hybridization. As a result, 4 equivalent orbitals called sp3 hybrid orbitals directed along the 4 corners of a regular tetrahedron are formed. When 2 such sp3 hybridized carbon atoms approach each other along the internuclear axis and overlap, a carbon-carbon sigma bond is formed. This bond has a bond length of 1.54 angstrom. 6 hydrogen atoms now approach and overlap the remaining 6 sp3 hybrid orbitals of both the carbon atoms, forming sigma bonds with bond length of 1.09 angstrom. In other words, whenever a carbon atom in an organic compound forms 4 sigma bonds which are directed along the corners of a regular tetrahedron, it is sp3 hybridized. Besides sp3 hybridization, the excited carbon atom may also undergo sp2 or sp hybridization. During the formation of a double bond, 1 2s and 2 of the 2p orbitals hybridize. Consequently, this hybridization is termed as sp2 hybridization. The hybridization leads to the formation of 3 equi-energic sp2 hybrid orbitals. As you can see, each sp2 hybrid orbital is bilobed, one lobe bigger than the other. The half-filled p orbital, which was not involved in hybridization, lies at right angles to the plane of the equilateral triangle. Now, let us understand how this hybridized state results in the formation of a double bond. For this, imagine a similar sp2 hybridized carbon atom approaching this carbon atom. As these atoms come closer, an orbital overlap takes place along the internuclear axis. This bond is called a sigma bond. At this stage, the unhybridized p orbitals which lie above and below the plane of the sigma bond also come very close to each other and overlap laterally, resulting in the formation of a pi bond between the 2 carbon atoms. Thus, there exists 1 sigma and 1 pi bond between the 2 carbon atoms. The other 2 valencies of each of the carbon atoms are satisfied by 4 1s orbitals of hydrogen, hence forming an ethene molecule.